In the past videos where I was experimenting with that fence wire underneath the power line, a number of people had asked me if I could go over the circuits I was using and try to explain them a little bit because they really didn't understand what was going on there. So in this video, I'm going to go over those two circuits I was using and kind of show the schematics and explain what was going on. The first circuit I was using is the one I was using to charge up the high voltage capacitor. And I was doing it this way because I didn't have the right tools to check what kind of charge there was between the fence wire and the ground. But I was able to check DC voltage, and I knew the size of the capacitor, so then I could see how much power was actually flowing in there. And here's a diagram of that circuitry. This will be the power line up here across the top, and this would be the fence wire or antenna, like I sometimes call it. And between the fence wire and the ground, there's a small 60 cycle AC current that's going to flow. This diamond shaped pattern right here, I have 4 diodes laid out. Now a diode is like a check valve. It only allows a current to flow through it one way and then is blocked from going in the opposite direction. So this arrow kind of indicates as being blocked by this wall here. So the current can only flow through this way. Now this fence wire or antenna is going to be influenced by the electromagnetic fields coming off the power line. So if it's being influenced in a negative charge, it's going to want to push electrons from the antenna wire to the ground. And it can only take the path that's allowed to go. So it'll be blocked here. It can't flow that way. It will flow this way, it cannot flow that way because it's being blocked, so it'll travel down and around, up through the capacitor, back around, and go that way to get to the ground. So now we have a little bit of a charge on the capacitor. Now when the cycle changes on the power line and influencing the antenna wire to a positive charge, it's going to try to draw electrons out of the ground back up to the antenna wire. But like before, the electrons can only travel in directions they're allowed to, and they're being stopped by these little check valves or diodes. So the electrons will travel up to here, they're blocked there, but they can travel around here, blocked there, but they can travel back around and add in some more charge to the capacitor, and they'll make their way back up to the antenna wire. And this cycling will keep continuing 60 times a second. And then I could just watch this capacitor being built up because I could check it with a DC voltmeter because I did have that. And then I stopped it when it got a little over 900 volts. So this is just a very simple circuit, full bridge rectifier. It's very common and it's just very simple. Now before I go on to describing that second circuit, a question that was asked a lot about this one was, how much power are you getting? Is there enough to run a house? Well, the answer to that is no. You can't run a house on it. It's just a small amount. And I can calculate how much power I was getting continuously by watching the capacitor charge up. By using this capacitor energy formula, I can get an idea how much power I was pulling in continuously. Where here we have E is equal to a joule. A joule is a watt second. So 1 joule is equal to 1 watt for 1 second. And C is in farads and voltage. And by taking voltage readings and how much time it was in between them, I can get an idea how many joules I was collecting over a period of time. For example, when I was charging up that 88 microfarad capacitor, at one point I had a test reading of 818 volts, and about 2 minutes later it was charged up to 907 volts. Now I can just take this formula here and calculate how many joules were stored at each point, or I could plug it into that online calculator and get the answer too. And these numbers here is how much that capacitor was holding at each point. And the difference is 6.76 joules, and that was about 2 minutes or 120 seconds. So we can just take the difference in joules and divide it by 120 seconds and come up with an answer of 0.056 watts a second, or 56 milliwatts of continuous power. So no, you're not going to be able to run a house on that, maybe some LED lights. If a fence under a power line had any significant loss, the power company just won't allow it. And this is very insignificant compared to the whole capacity of the power line, because the fence under a power line is being grounded out. The second circuit I was using with the spark gap was a runoff circuit of a base circuit I use in my aerial ground energy receiver. And that's a circuit I came up with in the 1980s after I seen Joe Tate's circuit of his ambient power module. He had made a circuit to collect energy off the radio waves. And I tried it out, and it did work, but I came up with my own that actually I think works a little bit better and is a lot less complicated. And I actually, a few years ago, put this in a experimenter's notebook, and this was the first basic circuit that I came up with, and it's pretty simple. And in the second circuit under the power line, this is what I came up with to form a spark gap. This second circuit I was using is sort of a variation of a half-bridge rectifier and a voltage doubler, because this does double the voltage, and that's why I'm able to have a spark gap. And these are the same silicone diodes that I was using in that other circuit, and they're rated at 1,000 volts. But in this case, I got them connected in a series because I knew I was going to be dealing with higher voltage. And this is the capacitor that will build up. I believe it was rated at 2 kilovolts. And then as it charges up, it'll eventually break the resistance of the air and fire. And I chose to go with this spark gap circuit because I think it'll be easier to reduce the voltage by putting it through an inductor, but that'll be in a later video. Hopefully I shed some light with my explanations of the circuits, and I'm going to continue working on a way to reduce the voltage so I can possibly run some LED lights, like a LED flashlight like I used in my crystal cells. So thanks again for watching this video, and I'll see you again.